Chapter 17, Problem 15. Calculate the boiling point and freezing point of a solution made by dissolving 110 grams of potassium phosphate in 800 grams of water at 1 atmosphere. For water, the boiling point constant is 0.51 and the freezing point constant is 1.86. So if we want to get the boiling point and or the freezing point of the solution, we're going to use the Chem equations. So the Chem equations, you can see, have the constants, which are given, the Van't Hoff factor, which we'll have to determine, and the molality, which we will also have to determine. So I'm going to start with getting the molality. So I have to get the moles of the potassium phosphate. So the molar mass was given 212.3 grams per mole. So that gives us 0.518 moles. And then we have 800 grams of water, which is 0.8 kilograms. So our molality is 0.518 per 0.8. And then our I value, if we look at the formula for potassium phosphate, we've got 3 potassium ions, 1 phosphate ions. So our I value is 4. And then we have our constants. Now notice that it's not asking us to find delta TB or delta TF. It's asking us to actually find the boiling point and the freezing point. So we need to know that the delta TB refers to the solution's boiling point minus the pure's boiling point, and delta TF, same thing. It's the solution's minus the pure. So the boiling point of the solution, that's what we're trying to find, minus the boiling point of the pure. Now, the boiling point of pure water is 100 degrees Celsius if you are at 1 atmosphere, which it is. So then we're going to set that equal to the boiling point constant, 0.51. And then our I value, and then our molality. So what we end up getting for the solution is 101 degrees. So the boiling point only went up 1 degree when we dissolved the potassium phosphate, but it did go up. So if we do the same thing with our freezing point, we want to realize that at 1 atmosphere, the freezing point of water is 0. We use the freezing point constant. Same I, same molality. And I almost forgot, there's a negative sign in the freezing point Chem equation. So the new freezing point of the solution is negative 3.61. So this is typically the case that the freezing point changes to a higher extent than the boiling point, but they're both going to change due to the presence of the solute.